Okay, in part one, we left off by identifying all parts of this continuous change function. And really that function, the name of it explains, it's continuously changing. It's continuously calculating the money that you are putting in or that you have put in the account each month. Okay, so again, the A of T is the result. Okay, so look over here, this is the formula, the equation that we're using, and what we end up with is the answer, the result. E is approximately 2.72. The initial amount that you put in is 1,000. The rate, I wanted to just clarify this, that when you are given a percent, okay, so a rate of interest, you need to change it to a decimal, okay, or tax, 6.5% sales tax. You need to change it to a decimal first. Remember, we take off the percent sign, and the decimal is located right here. We move it over 2 places to the left. That is where this number came from. That's the rate. And the time is how long you want to keep the money in. Maybe you want it in 2 years, or maybe you want it in 30 years, and then you can take out the money and you can use the money in 30 years for something. Okay, so make sure you understand all parts. Once you have that, then it's simple. You just take out each letter of your formula and you put in the number that we came up with from this problem. Okay, so let's just take a look. We're going to take out the P, the capital P. We're going to take that out and we're going to replace it with the initial amount, the $1,000 we put in. Inside, well, I am using parentheses to represent the E and represent the multiplication in this formula, in this equation. Okay, so what's the E? It's about 2.72. Now the exponent is the R. I know it might be a little hard to see, the R times the T, the rate times the time. So I'm going to take out the R and I'm going to put it in 0.0105. Okay, that's the rate as a decimal times the time, 10 years. Okay, so now I'm going to show you step by step. You could technically put this into your Desmos calculator just as you see it. I like to show my steps in case I push the wrong button on my calculator. So what I'm going to do first now, please excuse my dear Aunt Sally, please excuse the E is exponent. The parenthesis is only 2.72. It's only used to represent multiplication here. So you can't do anything with the parenthesis except erase it. So we'll get to that in a second. But the exponent, so you got to do the exponents first. Okay, I like to show all my steps. So here's the 1,000. Oh, I didn't color code it, sorry. Here's the 2 times the 2.72 raised to the 0.105. Where did I get 0.105? Multiply these two numbers together. Okay, so now here's your problem. Please excuse my dear Aunt Sally. We still have exponents. So you want to take this 2.72 and raise it to 0.105. Okay, so use your calculator. If you're using your cell phone, you can use this little button, X to the Y, I believe is the little button on your cell phone. Okay, so what you do there is take 2.72, hit this button, and then enter 0.105 equals, and what does that equal? 1.11, and that's rounded. Okay, now remember your answer, now you multiply these two numbers together, 1,000 times 1.111, your answer is not going to most likely ever be exact because we have approximated way back up here the e. So in general, it might not come out to be the exact answer, but this is what you get when you multiply it. So by you putting in $1,000 at this bank at this percent interest, which is kind of low, but after 10 years, you're going to come up with, in your account, you're going to have $1,110.78. Okay? That's how much you will have after 10 years. Eek. I mean, it's better than nothing, right? To find out how much you earned over, this is super small, over 10 years, subtract. Go ahead and subtract what you started with, what you have from what you started with. And you started with $1,000, right? So you made, by doing nothing but putting your money in an account, you made $110.78. Let me put a little subtraction sign here. Okay. So you made, and I'll just write this. Again, it's better than nothing. If you want to make more, there are different ways, different types of accounts. We'll talk about that all next semester. So you made this much money after 10 years. Okay, so any questions about that? Go back into the lesson, practice the problem, use your notes, and reach out to your. Okay, now I just want to share one thing with you. We do this in the lesson. This is actually in the lesson, but I really like this. The penny versus the $1 million debate. Which one's better? Would you rather get a penny that doubles every day for 1 month or $1 million? Which would you choose? So exponential functions change at a constant rate, and that is what makes your graphs go steady, then it shoots up, or it's going down super fast and then it levels out because it's increasing or decreasing at a steady rate. So would you rather get a penny that doubles every day for 1 month or $1 million? Which would you choose? So day 1, here's your penny. Here's your penny. There's your penny right there. On day 2, that penny doubles. Oh, remember a penny is one, it takes 100 pennies to make $1. So 1 penny is 0.01. If you double that, here's your 2 pennies. How much money do you have? You have 2 cents, right? Those 2 pennies double, so day 3 you have 4 pennies or 4 cents. Day 4, those 4 pennies doubles and you have 8 pennies or 8 cents. On day 5, those 8 pennies double and you have 16 pennies or 16 cents. On day 6, those 16 pennies double and you have 32 pennies or 32 cents. And after 1 week, those 32 pennies double and you have 64 pennies or 64 cents. Now, would you rather have $1 million or a penny that doubles every day for 1 month? I don't know. It kind of looks like that's only 64 cents after 1 week. I don't know. You might want to take the $1 million, right? Or no? Well, who really wants to sit there and double your pennies each day for 30 days? Yikes. So there's math behind all of these amounts, okay? And we can use an exponential model to represent this. So here's your penny, okay? And this is the exponential model. The penny times the first day is 1. The penny times 2 on the second day is 2 cents. Okay, so where'd the 4 pennies come from? Well, mathematically, it's the penny times 4, or 2 times 2. Okay, so this is a model, and this will help you calculate so you don't have to do the math. How many pennies do I have on 8 days? How many pennies do I have on 9 days? How many pennies, blah, blah, blah. So this is an amazing model for you to use to calculate how much money, if you just get a penny on day 1, but it doubles every day, how much money you'll have after 30 days. So here it is. It's 0.01, the amount of a penny, times 2 to the 0 power. Then it's 2 times the first power, then 2 times the second power. So the exponent is changing. Okay, and notice on day 7, it's the penny times 2 to the 6th power. So basically the formula is to calculate after 30 days, it's the penny times 2 to the days minus 1. Let's take a look. Day 30. On day 30, you have your penny times 2 to the 29th power. Why not 30? Why isn't the exponent 30? Well, because on day 1, it's just the penny, nothing more, nothing less. And how do you get just the penny? Well, we reviewed any number raised to the 0 power gives you 1. Okay, so this 2 to the 0 power is 1. 0.01 times 1 is your penny. Okay, so that is the formula. You take 2 to the days minus 1 exponent. So 0.01 times 2 to the 29th, go ahead, put that in your calculator. You want to take 2, raise it to the 29th power, then multiply by the penny, 0.01. Do you think it's more than 1,000,000 or less? That's what you get. What? $5,368,709.12. If anybody ever gives you this opportunity, take the penny that doubles every day for 1 month. This is a great problem for you to share with family members over the holidays. I hope you enjoyed it.